Hey guys, welcome back to my channel IFY Studio. In this video, we are going to explore the simple queue service commonly known as SQS. Before diving into SQS itself, we need to grasp an essential concept called pole-based messaging. Once we understand that, we'll examine how SQS fits into our architecture. Then we'll look at the various settings we need to configure. We will explore the different options available to set up SQS correctly, focusing on one key setting called the visibility timeout, which governs the interaction between our architectures and the messaging queue. Let's jump right in. Let's first understand what is pole based messaging. And here, I would like to think of it as a scenario we might all know from before. Imagine sending a letter to a friend. You write a nice note, put a stamp on it, and then give it to the mailman. And then the mailman delivers it to your friend's mailbox. And then once your friends find out, he or she can retrieve and read the letter whenever they are ready. That's exactly what pole based messaging is. Think of SQS as a postman delivering messages to the mailbox. We have a message producer, like a front end, that sends a message to the SQS queue, and the backend consumer can then retrieve the message from the queue whenever it's ready. Now, SQS is a messaging queue that allows asynchronous processing of tasks. But out of all the things which is written on the screen, the important point is to understand the word asynchronous. Now, the word asynchronous means, for example, there is service A, which is sending a message, which wants to send a message to service B, and we have SQS as a buffer in the middle. So, SQS in the middle will ensure that the message A is first receives by the service B and then acknowledge is received by service A. Till then, both the services can work independently. So, that's what asynchronous is. While SQS is simple, as its name suggests, there are many settings to understand to ensure it functions correctly. The very first setting is the delivery delay. Now, the default value for delivery delay is 0, but it can be set up to 15 minutes. The delivery delay does exactly what it sounds like. When a message is written to the queue, if the delay is set to something other than 0, the queue hides the message for the specified time before making it available to the backend instance. Now, the question comes, why would we want to delay messages, right? Now, let's imagine a web front end for placing orders. For example, Amazon. So we go and place orders, right? Now, users enter their credit card information and address, and we need to pass that information to the backend. And we might want to delay the notification to the user until the company verifies with the credit card company that the payment is valid, right? So we can set a delay between when the message appears in the queue and when the backend can process it. Next one is message size. And it's another important setting. Now, by default, you can post a message up to 256 kilobytes of text in any format. This is a crucial number to remember, okay? The format doesn't matter. It could be like a JSON, a YML file, or a plain text, but the maximum size is 256 kilobytes. Though you can adjust it down, but not above 256. Next comes the encryption. Now, encryption is also vital. Um, so, to understand this particular setting, this is mostly handled by AWS itself, but we have to understand this thing when the messages are in transit. For example, when we are sending messages from one service to the other, during the transit, it's encrypted by default. Okay, the AWS takes care of it. That encryption is simple, but when the message is at rest, for example, if the message has reached its destination, then in that at that time it's not encrypted. But that's not an issue. We can use a service called KMS, which helps us in providing a key, which is then used to encrypt your messages. So this is an important setting, but yeah, so you can configure this setting if you want to have like end-to-end encryption rather than just encryption on flight. Message retention is another critical setting. Messages don't live in SQS forever. Okay, by default they last for 4 days. Now 4 days is a default setting, but this can be set up to 14 days or as low as 1 minute. What happens after this period? Messages are then purged or removed from the queue. That means if you do not process them in time, they will be lost forever. Moving on, then comes the long and short polling. Now, there are two types of polling in SQS: short polling and long polling. Short polling means that the backend instance, or let's suppose that there is one EC2 instance which connects, checks for the work if any work is there or if any messages is there or not, and then disconnects and repeats. Now, this can be waste of CPU cycles and money due to very frequent API calls. Long polling, on the other hand, means the instance connects and waits for the messages. And this is not enabled by default, but it's generally the preferred method. And once the messages are available, it will disconnect and repeat the process. But this is usually preferable as it saves on time and API calls. Finally, queue depth. Now, queue depth is more of a value than a setting. As we discussed auto scaling in previous videos, right, where EC2 instance and load balancer in between, and it used to like scale up on the basis of the request. Now, EC2 instances can be triggered by various factors, including the depth of the SQS queue. So let's suppose that as the messages accumulate and it gets increases in depth or increases in size, we can use CloudWatch to trigger auto scaling as a service to add more instances to the batch and to process the data. And as the queue depth decreases, we can scale down the instances. Now, that's why queue depth is not a setting, but instead it's like a way to auto scale or manage your overflow. Now, we have covered the key settings, and a few will be discussed shortly, but it's very crucial to know the defaults and understand the impact of changing any of these settings. That being said, we are still left on a very crucial settings we haven't discussed. It's called the visibility timeout. To have a better understanding, let's explore what this setting signifies. So here is the basic setup of SQS decoupling. We have seen this diagram before, happy user. So let's assume that the happy user here submits an order to the EC2 instance, and the EC2 instance then places the order in SQS queue. And then the backend EC2 instance checks the queue asking, hey, do I have any placed orders? And when the service B or polls the queue will say, yes, there is a message. Let's process it. Now let's imagine the interaction between the backend instance and the queue. The order arrives and the message is placed in this SQS queue. The visibility timeout ensures that the backend EC2 instance handle the message correctly. So when the backend instance polls a message, it recognizes the order from the user, and the SQS acknowledges the message downloads and locks it. And this setting is known as visibility timeout. This setting is configurable. By default, we have a 30-second window, and during these 30 seconds, the message still stays in the queue but is invisible to the others. Now, let's suppose that if other instance polls the queue, it will appear empty, even though the message is present but hidden. What if the backend instance fails to process the message within those 30 seconds and does not inform the queue that it's done? The message will reappear. Now, this means that if the instance goes offline or fails, the content isn't lost. So, we are always safe on the content side. That is why the visibility timeout is essential for the SQS queue. And assuming everything goes smoothly within the 30 seconds visibility timeout, the instance confirms completion saying, hey, we are good to go. The queue then deletes a message indicating that it's no longer needed. Understanding this interaction is very crucial, so you can just skip back, watch it over just to understand how this interaction happens. I promise we'll have some hands-on activities with SQS in our next video. Again, this is the end of the video, so before leaving, here's a pro tip for you. SQS is an excellent service if its settings are understood correctly. Thanks for exploring SQS with me, and I look forward to seeing you in our next video. Peace out.